So in this video, we're going to talk about difference of squares, perfect square trinomials, and sum and difference of cubes. Difference of squares is where we're going to start. It is literally a difference of two things that's being squared. So it's going to have a format a squared minus b squared. It's always going to factor in a plus b times a minus b. So if we look at this one, we have x squared minus 49. So this is perfect square, this is perfect square. So it's going to factor into x plus 7 times x minus 7. Okay. The reason that works, if we were to multiply this out, I would get x squared. Outside is 7 minus 7x, inside is plus 7x, and then minus 49. So you can see how those middle terms are going to cancel out always. That's always going to happen with a difference of squares. In the next one, we have 9x squared minus 25y squared. So again, difference of squares. 9x squared is a perfect square. 25y squared is a perfect square. So it factors into 3x plus 5y and then 3x minus 5y. Perfect square trinomials. Really, this is just factoring the way that we would normally factor when we talk about perfect square trinomial. So this first one is not a perfect square trinomial. It's just kind of a hidden, that does not show up very well. This one is a hidden difference of squares. Let's factor out the GCF. GCF is a 4x squared. So if I factor 4x squared out, that's going to leave me with x cubed minus 8. We actually need to move this to a different section because this is going to be a difference of cubes. So this is a hidden difference of cubes. So we'll come back to this one. I'll start for now. I think that is in the wrong section. So example 2, we have 4x squared minus 12x plus 9. We're just going to use our AC method here. It's not a difference of squares. Difference of squares would have two terms subtracted that are perfect squares. This one has a middle term. So we're going to use our trusted AC method. A times C in this case is 36. Thinking about what can I multiply together to get 36. So I have 2 and 18, negative 2 and negative 18. That's not quite there. Nine and 4, negative 9, negative 4. That's not quite where we need it. We need it to be a negative 12. So we need, let's try 6 times 6 and negative 6 times negative 6. And there's my combination. Negative 6 times negative 6. So we're going to do a rewrite. 4x squared minus 6x minus 6x plus 9. Group the first two together. We can factor out a 2x, leaving us with x minus 3. Group the second two together and factor out a minus 3, leaving us with, I forgot my 2 there, 2x minus 3. And now you can see we have that 2x minus 3 in common, leaving us with 2x minus 3. Our factored form is going to be 2x minus 3 times 2x minus 3, or 2x minus 3 squared. Okay, but the process is the same. Still using that a times c, still breaking it down, trying to figure out which combination is going to give you that middle, and then doing the rewrite step. Difference of cubes is a little different. With difference of cubes, you have formulas. So a cubed minus b cubed, it's important to figure out what I'm cubing to get that a cubed and what I'm cubing to get b cubed. It's going to be a minus b times a squared plus ab plus b squared. sum of cubes is a cubed plus b cubed. So I've got binomial here. And it's going to factor into a plus b times a squared minus ab plus b squared. So let's look at the first one. We have x cubed plus 8. So I'm going to view this as 2 cubed plus, x cubed plus 2 cubed. So I'm using the sum formula. So a cubed plus b cubed is a plus b, a squared minus ab plus b squared. I just have to figure out what my a and b is going to be. In this case, a is going to be x, b is going to be 2, and I'm literally just plugging it in here. So it's going to be x plus 2 times x squared minus x times 2, which is 2x, plus b squared, and 2 squared is 4. The next one, I have 27x cubed minus 64y cubed. So I'm going to view that as 3x quantity cubed minus 4y quantity cubed. So my difference of cubes formula, a cubed minus b cubed, is a minus b times a squared plus 2ab plus b squared. A squared plus ab plus b squared. I am thinking about something else right now. So let's figure out what we're using. So my a is going to be 3x, my b is going to be 4y, and I'm just going to plug everything in. So I'm going to get a minus b, 3x minus 4y, and then I'm going to get a squared. So if I take 3x and I square it, I'm going to get 9x squared, plus a times b, so 3x times 4y is a 12xy, plus b squared. So that 4y squared is going to be a 16y squared. So there's my answer. Now, let's go back to the one that we started above. We had 4x to the 5th minus 32x squared. We factored out a 4x squared. That left us with x cubed minus 8, and this is a difference of cubes. So now we're to the point where we can finish the problem. Factored out a 4x squared, leaving us with x cubed minus 8. Difference of squares formula, a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So my a is going to be x, my b is going to be 2. So when I break that down, I'm going to get 4x squared. So that's on the outside. That's what we pulled out. This is going to be a minus b, x minus 2 times a squared. So x squared plus a times b, which is 2 times x, plus b squared, 2 squared, which would be 4. So there's my answer. So let's do a few more. We have 4x squared minus 100, and we want to factor this. So we could think about what these two have in common. They do have a 4 in common. That's going to leave us with an x squared minus 25. And this guy is a difference of squares. That's going to leave us with x plus 5 times x minus 5. Now, we could have viewed this as a difference of squares to begin with, and that would have been okay. We would have done a little bit more work to get to that final answer, because that 4x squared is a perfect square, and the 100 is a perfect square. 4x squared breaks down into 2x times 2x. 100 breaks down into 10 times 10, plus and minus. And then we're going to see what they have in common. These two, I could pull a 2 out, leaving us with x plus 5. And then these two, I could pull a 2 out, leaving us with x minus 5. And then I have a 2 times 2, which is a 4. So I have 4 times x plus 5 times x minus 5. Either way will get us to the same answer. So notice in this, I pulled a 2 out of the first group and a 2 out of the second group. These are multiplied together. I am not adding the two groups together. So it's not really a GCF for the parentheses sets. It's a GCF for each one individually. That last one, we have 2x cubed plus 54. We're going to think about what they have in common. We could factor a 2 out, leaving us with x cubed plus 27. So this is a sum of cubes. A cubed plus b cubed is a plus b times a squared plus ab plus b squared. In this case, our a is going to be x. And if I take 3 and cube it, I'll get that 27. So I can break that x cubed plus 27 down into x plus 3 times a cubed, a squared, which is x squared, plus a times b, which is 3x, plus 3 squared, which is 9. 2 times x plus 3 times x squared plus 3x plus 9. There's my factored form.